Welcome to Statistic Learning Session. Today we'll be talking about goodness of fit test. This is going to be an example, a problem we want to solve. And for that, we'll have a setup and we'll give example of problem that matches the setup. Now let's get started. We have a IID that's called X, and there are n instances of IID 1 through n, and it has a distribution of P, and this belongs to a simplex of K. And next we have P naught. It also belongs to simplex of P, simplex of K. Now, what we want to do is we want to test whether the distribution of P, the distribution P of X is close to P naught. That's what we want to test. For that, we need to start with going back to our previous examples and define what P naught is for our purpose. Let's go back to the previous example and see what P naught is. In this example of jurors and identical groups, racial groups, what we have is a different races in a county. And I want you to think, take a few seconds to think what's going to be P naught here. The P naught in this case is the ratio of the proportion of the races in the county. That's going to be P naught, and that is, it's going to be this value here. P naught is equal to 0.72 to 1. All those values belong to P naught. And we have other example too. Remember the example about star sign or zodiac sign. In this zodiac sign, we had a CEOs of people, and we consider them to be successful. And we want to know what is the probability that if you have a star sign, what's the probability if you have a 12 star sign, what's the probability that of each of the star sign being a CEO? That's what we know. And for that, and we believe that from our good heart that every star sign has equal probability. Therefore, the P naught should be, for all 12, P naught should be 1 by 12. And this is a P naught we have. Now, going back to our slide, which we have been discussing so far, we have this slide, and it says H naught is equal to P naught. Here, P naught is actually new zero. It's a new zero. P naught is actually a new zero, and what we are saying is that whether P is equal to P naught, else the alternate hypothesis is P is not equal to P naught. That's going to be a discovery. Now, the example we have is P naught is equal to a set of values called 1 through k, 1 by k up to k times. And we are testing whether P is equal to that. This example is closely related to a zodiac sign, where we are testing whether P is uniform on E. That's what we are testing. Now, can you tell me what kind of test can we use to determine whether P is equal to P naught or not, or else? What are tests we can use? Can we use t-test? Of course not, because t-test is used for a Gaussian-like distributions. This is kind of a bit different, and this is not a Gaussian distribution, but and it is not a continuous distribution either. This is a more discrete distribution, and on top of that, we cannot use t-test because it is used for a Gaussian-like distribution or bell-shaped distribution, but this is not a bell-shaped distribution. So tell me, what do you think? What are two tests we can use? Let me tell you, the two tests we can use here is one, firstly, the likelihood ratio test, which is a kind of a Wallace test but in one dimension, and secondly, a Wallace test itself. So those are two tests we can use. Now, before we use those tests, we actually need to find a PMF of our data because it's a discrete distribution, remember? We need to find a PMF of our data. And that's what we're going to stop today. So let's summarize this. What we learned today. We learned about a goodness of fit test for a random variable x with a distribution p that belongs to the simplex k. And we had a p naught, which is a new 0 that also belongs to simplex of k. And we want to test whether p naught is closely related to p naught. P is closely to p naught. That's what we want to test. And we look at a few examples from what we did earlier in classes. And then we took a general example of zodiac test. And we said that we want to test whether P is uniform on E. So that's all for today. I will see you next learning session. Thank you so much.